maintenance call in Brevard, North Carolina.
All right, so the first thing we're going to do is check our supply temperature with our return to get our delta T, or our temperature split. The goal is to have at least 16, 20 to 20 degrees in AC mode. Right now we're reading 17 degrees with a 64 degree return and a 47 degree supply, which is acceptable. It's important to document everything that you can. Take a lot of photos. The layout photo. All of the data plate information. One of the other things we're going to check is the humidity. Right now we're just coming into late spring, and the humidity inside is already at 45%, which is acceptable. We have a ducted dehumidifier in this application. So humidity is good. Then we're going to go ahead and kill the power and get this guy opened up. Inspect all the wiring. Nothing looks burnt or loose or compromised in any way. Alright, we're going to inspect our evaporator coil here. We're going to document what we see. A little bit of buildup there, but nothing's impacted. Nothing that's going to prevent airflow. So from the top side is good. And then we're going to check this blower. Now I know from previous history that this motor, this fan motor, is on its last leg. There's pretty significant play in this shaft, and I'm going to demonstrate that for you here. I'm going to record a little video. Previous history. I'm going to reach in here and grab the shaft. A little more movement than we would like. Not as bad as I remember it last time though. We still have some pretty significant horizontal play. Alright. I'm going to go ahead and document our electrical wiring here. Alright, now we're going to check our capacitor. We can read on here that it's a 10 UF plus or minus 5%. Voltmeter here. And what we're going to do is going to pull one of these wires off. Check our microfarad. 10.18, which is well within the acceptable tolerance. Alright, we're going to inspect the drain here. Looks okay. I'm going to show our drain before and after we clean it. This one in this case is not bad. There's nothing I can see in there. We do have the correct P-trap here. And it is insulated to protect from freezing. Flush it just a little. We're going to run a brush through just to make sure nothing's stuck in that P-trap a couple times. And we're also going to run it into the primary drain pan, which is below the evaporator coil, and then give her a good flush on the second go round. Getting into the season where these things are going to start producing a lot of condensation. Always clean your drains. Fill that P-trap back up with water so we don't lose any airflow. And then we're going to take another photo after we've done that, just to verify trap is full, drain is clear. Now, we're going to check to make sure our plenums are sealed. We're just going to document everything looks. We're going gonna go ahead and slap the door back on this guy. This system here has been around for a while. At this point, the goal is just to keep it running as long as we possibly can. And now it's time to move on to the outdoor unit. Note the time for the 5-minute delay. I'm just getting prepared for this thing finally kicks on after the 5-minute delay. It's not all unicorns and rainbows. Sometimes you open one up to this site. 2006, so it is 19 years old. We replaced the TXV on this one last year, the outdoor TXV. I'm gonna go ahead and turn it off and get this cleaned up. Pull our disconnect, double check, make sure each leg to ground, we're good, no power. I'm gonna go ahead and get rid of that guy. That's what I thought that's what I wanted to show you. When I said it's not all unicorns and rainbows, this is what it's like in the real world. That was that mouse laying there in that. Okay, so you hear the buzzing noise. That is from the low voltage coming from this contactor. You can hear it's just showing some signs of stress. There's some significant burnt and pitted spots at the contacts. We're going to check our voltage drop from line side to load side, and it'll tell us some more about what we need to know. So we're going to check our fan amp draw. It's running at 0.47 amps, which is okay. Now we're going to check our contactor. We're going to measure our voltage drop. So we see here we have 241.3 volts on the line side, and on the load side going to the equipment, 241.2. So even given the state of the contactor, the voltage drop is minimal. Now we're going to check our low voltage. We need at least 24 volts here. At 25.6 volts on the low side, that's good. And then now we're going to enter it in and document everything. I'm just going to go ahead and snap a photo of this contactor. Pressure's running at 5.1 amps. We're going to see how that compares to startup. Now we're going to kill the power again and check our capacitor. So the formula for checking the capacitor while it's running is we're going to do our amp draw times 2652, which is the formula, divided by our voltage. So our amp draw was 5.12 amps times 2652, which is the formula, divided by our voltage of 331.6. And that tells us our microfarad or MFDs are 40.9. And this is a 40 UF capacitor, so our capacitor is good. All right, now we're going to kill it anyway. Oh, yeah. Common to Herm. 40.34. Formula was off a little, but still pretty close. That's on the compressor side. Now we're going to check the capacitor for the fan, the outdoor fan. This should be a 5, plus or minus 6%, so we are, we're good. Capacitor's within range. And again, we're going to check all of our wiring connections. We're going to have a conversation about this capacitor about this contactor with the client. Our delta T was good. Our amp draws are within range. It was a little dirty, but for a 19-year-old unit, functionality is key, and this one is functioning about as good as we could ask for. We're going to check our amp draw on startup. Just text our max amp draw. Turn the power back on. Here we go. 5.1 amps while running, 16.5 max amps on startup. If we were to see that get too crazy, we could install a hard start or something like that to help this thing out. But in this application, I don't think we really need it. We'll still give the client the option. And that is pretty much it for the maintenance process. 2 systems here, and now we'll get all packed up and tidied up and do it again.